Welcome to aminacademy.com. In fluid mechanics, let us discuss about loss of head due to sudden enlargement of the pipes. Consider a liquid flowing through a pipe which has sudden enlargement like as shown in figure. Consider the section 1 and 2. This is section 1 and this is 2. Here this section 1 is before enlargement, section 2 is after enlargement. Let P1 pressure intensity at 1. Here let P1 is pressure intensity at 1. V1 equal velocity of flow at 1. A1 area of pipe at section 1. Area of pipe at 1. Similarly, P2, V2, A2 for section 2. Now, here this is the velocity V1, here the velocity V2, this is here force is P1, P1A1, intensity of force, here P2, V2 is acting this side. Now, due to sudden enlargement of diameter of the pipe from D1 to D2, the liquid flowing from the smaller pipe is not able to, suppose the liquid is flowing through the smaller pipe and suddenly it's enlarged, it's flowed through enlarged pipe, and this is not able to the abrupt change of boundary. That means smaller pipe is not able to flow the abrupt change in the boundary. Thus the flow separates from the boundary and turbulent eddies are formed due to sudden enlargement of the pipe. Here this is a turbulent eddies produced. The loss of head or energy takes place due to formation of these eddies. Let P days pressure intensity of liquid eddies that is on the section A2 minus A1, that is this enlargement section, this changing area section, these two things. Now HE, loss of head due to sudden enlargement, due to sudden enlargement. Now applying Bernoulli's equation, applying Bernoulli's that is P1 by rho g plus V1 squared by 2g plus datum Z1 is equal P2 by rho g plus V2 squared by 2g plus datum Z2 plus loss due to loss of head due to sudden enlargement. Now here the datum are equal, that is Z1 equal Z2. Therefore, we can write P1 by rho g plus V1 squared by 2g equal P2 by rho g plus V2 squared by 2g plus loss due to sudden enlargement, that is He. From this we can get it He equal P1 by rho g minus P2 by rho g plus V1 squared by 2g plus P2 by V2, sorry, V2 squared by 2g minus consider the control volume of liquid. Consider controlled volume of liquid in section 1 and 2. Then the force acting on the liquid in the control volume in the direction of the flow, that is force acting in horizontal direction, Fx equal P1A plus P1 A2 minus A1 minus P2 A2. Here this is P1 A1, the pressure intensity this side, and also pressure due to eddies is P1 minus P1 into A2 minus A1, and P2 V2, the force is opposite direction, so we are using minus here. So after opening this P1 A2 and P1 into A1, so we have Fx equal P1 minus P2 A2. Here this He, let it be equation 1, this is equation 2. Now momentum of liquid per second, therefore momentum of liquid per second in section 1 equal mass into velocity. Here mass is rho1 A1 V1, that is rho1 into volume, density into volume, rho is rho into A1 V1 into velocity at section 1 is V1, so which is rho A1 V1 square. Momentum of liquid in section 2, therefore next momentum of liquid per second in section 2 same is here, rho A2 V2 square minus, it is rho to A2 V2, rho A2 V2 into V2 equal rho A2 V2 square. Therefore, change in momentum therefore, you can write change in momentum equal rho A2 V2 square minus rho A1 V1 square. From continuity equation, continuity of flow equation, we have A1 V1 equal to A2 V2. From that, we can get A1 equal A2 V2 by A1. Therefore, change in momentum per second equal rho A2 V2 square minus rho, we are substituting A1 values here, A1 values here will get rho into A2 V2 by rho to A2 by V1. So into V1 square, therefore which is equal, by simplifying you will get rho A2 V2 square minus rho A2 V1 V2, because this one square is cut. So further we can take out common rho A2, that is V2 square minus V1 V2. Now net force acting on the control volume in the direction of the flow must be equal to the rate of change of momentum. Therefore, net force equal rate of change of momentum. Therefore, you can write P1 minus P2 A2 equal rho A2, let it be 3. Here rho A2 V2 square minus V1 V2. From this, P1 minus P2 by rho equal that A2 cut, and which is equal V2 square because rho come down, V2 minus V1 V2, dividing throughout by G. Further we will give some space for here. Then dividing throughout by G, we have P1 minus P2 by rho G equal V2 square minus V1 V2 by G. Substituting this value in 1, We have in one that equation, this HE, head loss due to sudden enlargement, is P1 by rho g minus P2 by rho g, and V1 square minus V1 square over 2g and V2 square by 2g. You are substituting these values in this equation 1. You are having now HE equal V2 square minus V1 V2 by g plus V1 squared by 2g minus V2 squared by 2g, which is equal to V2 squared minus 2V1 V2 plus V1 square minus V2 square over 2g. Here this is 2V2 squared, 1 V2 squared cut, so V2 squared, V1 squared plus V2 squared minus 2V1 V2 equal V1 minus V2 whole squared by 2g, which is equal head loss. Therefore, head loss due to sudden head loss due to sudden enlargement of the pipe equal He equal V1 minus V2 whole squared by 2g. We have done. Please subscribe our YouTube channel.